Okay, so if complex fractions are fractions within fractions, the way we want to simplify these is we want to undo that. We want to rewrite this in a way where we don't change its size, of course, but we change it so that it gets rid of these smaller fractions. So what you can do to make that happen is you can say, well, I'd really like to multiply this fraction by 2 because times 2 divided by 2, those would cancel out. Obviously, you can't just do that because it's like you're pretending like that 2's not there. But it is okay, it does mathematically say equivalent if you multiply everything by 2. Because now it's like I'm multiplying the denominator by 2, and I'm multiplying the numerator by 2, I'm just distributing it. And I'm multiplying the numerator and denominator by the same number, it's really like you're multiplying by 1. Now, even though I multiplied this by 2, that's great, it gets rid of this smaller fraction, but that's not enough to get rid of this one. So you realize, well, over here, I'd really need to multiply by another 2, because then that's like 4, and that would reduce that one out. But if you're going to multiply this fraction by 4, this fraction needs to be multiplied by 4, and that fraction has to be multiplied by 4 too. And then you go and look at this one, and you say, okay, well, 2 divided by 20 would be 1 over 10. 2 over 10 would be 1 over 5. So this 4 that I have is not quite enough. I really want to multiply this by 20. So this is missing a 5. So that all of that cancels. But again, now I'm multiplying this fraction by 20. So I really have to multiply this fraction by 20 and this fraction by 20. It doesn't matter, you can multiply it by whatever you want to, but you have to do it to all of them. So in the end, this stuff canceled out this denominator and left 5 times 1 plus this stuff canceled all of the denominator and just left the 3. And down here, the 2 canceled out this 2, but left a 1 times 2 times 5, which is a 10. So it gets kind of messy, but as long as you understand the process, you're usually left with something that simplifies easily after that. Of course, I kind of did that the long-winded way. I started off by multiplying by 2, and then I realized I needed something bigger, so I ended up multiplying everything by 4. And then I realized I needed something bigger, so in the end I multiplied everything by 20. So it's a much better idea if you just think about what you need to multiply by from the beginning. So don't multiply all this stuff by 3, and then realize you need to multiply all of it by 6, and then realize you have to multiply it all by 18. Just go ahead and start off by multiplying it all by 18. All of the terms if you're going to do that. So this works out perfectly here. Times 18 divided by 18, those just cancel. These would reduce. 18 divided by 6 is 3. And these reduce. 18 divided by 3 would be 6. Make sure you're keeping up with your work. And then you should be pretty close to finish. The only thing left here is 5 plus 1 times 3 divided by 1 times 6. So in the end we get 8/6. But that one reduces to 4/3. So what I'm really doing is I'm multiplying the top of my fraction by 18 and distributing it, and multiplying the bottom of my fraction by 18. So it's like I'm multiplying by 1, and it makes all of these small denominators go away. So you try that with number 3, another one that just has numbers. What would be wrong? So between 4, 5, and 5, the smallest thing that you could get away with multiplying by to make all of these smaller denominators go away would be 20. So if you want to multiply everything by 40, that also works. If you want to multiply everything by 400, that also works. Just that you're going to have more simplifying if you make the smallest thing. So times 20 divided by 4, that's like timesing by 5. Times 20 divided by 5 is like multiplying by 4. Times 20 divided by 4 is like multiplying by 5. So you end up with 5 times 3 minus 1 times 4 all over 1 times 5. And again, usually once you get to that point, now, technically, I guess you could type this question in your calculator since all this is just numbers, but you'd have to be very careful about putting all the parentheses around the fractions, the big fractions and the small fractions. They give you a decimal, but you do math enter and change it up. So I guess you could check that, but it would be pretty tedious. Okay. Did y'all ever do that in past years? No? All right. So even if you did, you probably didn't throw in some variables in there. Which of course we're going to do with algebra. So we still want to approach this the same way. Between 2, 3, 10, and 5. I could multiply everything by 2, but it's only going to make one denominator go away. I could multiply everything by 10, and that would make 3 of them go away. I can multiply everything by 30, and that would be even closer. But if you only multiply by 30, you're still going to have this x in the denominator and this x in that denominator. And we're wanting to get rid of all of the smaller denominators. So this time, we need to multiply everything by 30x. So 30x times 1 divided by 2 would be 15x. 1 times 30x divided by 3x. Well, the 3 goes into 30 10 times, and x divided by x just cancel out. So we're left with 10. Um, 3 times 30x would be 90x. Divided by 10 ends up giving us 9x. And then this x and this x cancel. 5 goes into 30 6 times. 6 times 1 is 6. With this one. Okay, so since I'm multiplying everything by 30x, I said 10 goes into 30 3 times. And then I had a 3 times an x times a 3. So 9x. 5 goes into 36 times, the x is reduced out, and you're left with 1 times 6, which is 6. And you do need to be careful that nothing else will simplify here. You need to consider, if you took out a GCF here of 5, and you took out a GCF here of 3, see what happens when I did that? I didn't think anything would cancel like this. So if you take out the GCF, then looking at this, I was pretty sure nothing would cancel, but it actually does. So in the end, 5/3. That's why you really have to make a habit out of forcing yourself to simply reduce. It's not going to happen a lot, but when it does, you want to make sure that you're ready for it. Okay, so the only difference was I had to throw an x in there to make sure that all of the denominators went away. So to go one step further, kind of like we did with the adding and subtracting, let's jump over to question 10, and let's look at that one together before we do a few more. So I know I'm going to want to multiply this by x minus 4, because I want these to cancel. So I know everything's going to get multiplied by x minus 4. I know I want this to be multiplied by x minus 10 because I want these to cancel. And mathematically, you could multiply them all by x squared minus 14x plus 40, but it's going to get really messy and hard to simplify your answer down in the end. So instead, factor this and realize that x squared minus 14x plus 40 is really the same thing as x minus 4 times x minus 10. We don't need to multiply everything else by anything. I'm already canceling out the things that need to be canceled. Okay, so here I've got x times x minus 10 plus 4 times x minus 4 and down here all of this denominator went away. They canceled out perfectly, which I couldn't see until I factored it. So then all of that goes to this. Okay, and I'm suspicious that it might simplify more. I shouldn't just assume that it's not going to simplify more. So even if it doesn't, I need to consider what would the numerator look like factored? What would the denominator look like factored? And sure enough, the numerator and denominator share a factor. That is not going to be easy for you to find if you don't train yourself to consider going further. X minus 8 over 5. So the moral of that question, we saw with adding and subtracting, don't just multiply everything by all the denominators. Factor this to see what it's made up of, and you may not even need to multiply anything else. I do not need to multiply anything else there. Okay. I would like you to try 2 of these to help you catch some of your mistakes you may make. And so let's pick out number 5. Looks to be a little bit easier than number 6. So do those 2 first, please. Obviously, you can work ahead if you do those. Also, I have a small factor on here that you need to create before I forget. Question 11. This is not supposed to be question 11. There's no like arithmetic sign here. This was supposed to be question 11, and this was supposed to be question 12. So just cross that off. Don't use that. But anyway, do 5 and 6 as a quick check to see where you're at. We'll check those, help you maybe figure out some notes you need to leave for yourself on what to do, and then you can jump back to the add and subtract worksheet and spend the rest of the class on that. This worksheet does not have to be completed before class next time. If you have class time to work on it, then that's good. The add and subtract that we started before lunch will be due. So
It's still supposed to be here. Anything back though, so.
Okay, so of those two, number 5 should have taken you a little bit less, but you need to see that you dealt with this 2 and this 1 correctly, because those returns 2. Just because you don't see a denominator doesn't mean that there's not a denominator 1. You should have multiplied this by 2x, this by 2x, but also those two. You can't just multiply part of the numerator by 2x and part of the denominator by 2x and do the whole thing. So if you did that, you had 4x minus 1 over 2x plus 10. Got the 2 out of that denominator, but that's not going to cancel out anything in the numerator. So you can if you want to, but it's not necessary there. At least talk about it. I'd say 6 may mess a few more people up because of the x squared. Between 8, 2, 12, and 3, looks like 24 would be the best number. And between no x's, x to the first, and x squared, you're going to need an x squared. Okay, so this 8 could reduce this 24 to a 3. This 2 could reduce to 24 to a 12. But also, remember x squared is x times x. So it's like this x could cancel out one of those x's. 12 goes into 24 2 times. X goes into x squared 1 time. That was 1x. 3 goes into 24 8 times. And x squared divides out x squared perfectly. Again, you need to take notice of how messy it can get very, very quickly. So, in the end, it looks like this was 3x squared times 1 minus 1 times 12 times x. This division bar is this division bar. This should be 2 times x times 1 minus 1 times 8 and I don't think anything else is going to reduce, but to be sure, it doesn't take me but just a moment to go ahead and factor out a GCF out of both of those. And so if I thought nothing else was going to reduce, I was wrong. If at the GCFs, you'll see that they both had a factor of x minus 4. So this gets all the way down to 3x minus 2. Or 3x over 2. question 5 and 6, any particular questions? Any steps in there I'm going over too quick that you want to ask and clarify? So then the other 4 questions on here, if you have time to get to some of those today, that would be great.